Welcome to Chapter 11. In previous chapters, we learned about the Ethernet, the services that a data network can provide to the human network, examine the features of each layer of the OC model, and the operations of TCP/IP protocols. In this chapter, we will learn how to combine these elements together in a functioning network that can be maintained. Networks are essential to human activities, and a lot of organizations depend on their computers and networks. Someone outside of the organization can attack the network through software vulnerabilities, hardware attacks, or guessing someone's password and username, and it could be dangerous. If a hacker gains access to the network, there could be some threats, like information theft. That is, when a hacker obtains confidential information of an organization. Another threat is identity theft. It's when someone steals personal information to take someone's identity. Data loss manipulation is when someone breaks into a computer to destroy or alter data records. And disruption of service is preventing legitimate users from accessing services to which they should be entitled. Another vulnerability is the physical security of devices, and there are 4 types of physical threats. First one is hardware threats, that is physical damage to servers, routers, switches, cabling plant, and workstation. Environmental threats, electrical threats, and maintenance threats. There also could be security vulnerabilities that are divided in 3 types. Technological, that are network security weakness, like TCP/IP protocol weakness, operating system weakness, and the network equipment weakness. Configuration, like for example, unsecure user accounts or accounts with easily guessed passwords. And the third one is security policy, that for example is not having a disaster recovery plan. Now we're going to talk about vulnerabilities and network attacks. First one, we need to know what is a malicious code attack. A malicious code attack is a computer program that was created with the intention of causing data loss or damage. And there are 3 types of malicious code attacks, that are viruses, Trojan horse, and worms. A virus is malicious software that is attached to another program to execute a particular unwanted function on a workstation. We can identify a virus because they normally require a delivery mechanism. A Trojan horse is different only in that the entire application was written to look like something else, when in fact it is an attack tool. Worms are self-contained programs that attack a system and try to exploit a specific vulnerability in the target. Upon successful exploitation of the vulnerability, the worm copies its program from the attacking host to the newly exploited system to begin the cycle again. There is also possible that networks could fall because of various network attacks. Network attacks are classified into 3 major categories. Recognized attacks, that is the unauthorized discovery and mapping of system services or vulnerabilities. Access attacks, that is the unauthorized manipulation of data, system access, or user privilege. And the denial of service, that is the disabling or corruption of network systems or services. For keeping a network safe, we can use some instruments to prevent the network's attacks and malicious codes. For example, the antivirus can detect most viruses and many Trojan horse applications and prevent its consequences. It works as a defense against some attacks. In the other hand, we have the AAA, authentication, authorization, and accounting. It's a way to control who is permitted to access a network, what they can do while they are there, and to watch the actions they perform while accessing the network. Authentication is when someone must prove they are who they say they are through a username and password combinations. Authorization is after the user is authenticated. Authorization services determine what user can do and what resources they can access. And accounting records what the user does. Part of a network security is securing actual devices. To apply this, there are some steps that are important to secure devices. The first one is default usernames and passwords should be changed. Access to system resources should be restricted. And any unnecessary service and application should be turned off or uninstalled. For the step number 1, there are some recommendations that should be applied. To protect network devices, it is important to use strong passwords. Here are standard guidelines to follow. The number 1 is use a password length of at least 8 characters. Make password complex. Avoid passwords based on repetition. Deliberately misspell a password. Change passwords often. And do not write passwords down and leave them in obvious places. In this part, we put some images that explain the different files systems and how we can access to them.
When planning a network, there are 4 things that you must take into account. In first place, the cost, which is determined by the equipment capacity and features, in other words, by the number and type of ports available. Then, there's the speed and types of ports on the routers and switches. Third is expandability. Networking devices come in both fixed and modular physical configurations. Fixed configurations have a specific number and type of ports or interfaces. Modular devices have expansion slots that provide the flexibility to add new modules. Last but not least, you must think in the operating system features and services. When implementing a small network, it is necessary to plan the IP addressing space because all hosts within an internetwork must have a unique address. Planning and documenting the IP address scheme helps the administrator to check device types. In order to maintain high degree of reliability, redundancy is required in the network design because it helps to eliminate single points of failure. It can be accomplished by installing duplicate equipment or by supplying duplicate networks links for critical areas. Also, to help ensure availability, the network designers must prioritize the traffic. Voice data is transmitted first, then mail data, then instant messaging, and finally files. In the end, the goal is to improve productivity of the employees and minimize network downtime. Within the application layer, there are two forms of software programs that provide access to the network applications and application layer services. Network applications communicate directly with the lower layers of the protocol stack, for example, email clients and web browsers. Application layer services provide assistance to other programs to use network resources, like file transfer. Common small network protocols include DNS, Telnet, IMAP, DHCP, HTTP, and FTP. To scale a network, several elements are required. First, network documentation, which describes the physical and logical topology. Second, a device inventory, which is the list of devices that use the network. Third, a budget. And fourth, traffic analysis of protocols, applications, and services and their respective traffic requirements. Protocol After a network has been implemented, a network administrator must test the network connectivity to ensure that it is operating appropriately. One option is to ping for testing the protocol stack as the ping command moves from layer 3 of the OSI model to layer 2 and then layer 1. Another option is to trace the hops as a packet is routed through a network. Also, show commands display relevant information about the configuration and operation of the device. For example, the show version command can be used to verify and troubleshoot some of the basic hardware and software components used during the boot up process. It displays the software version, the bootstrap version, the system uptime, and the system restart information, among others. Other important commands are jpconfig, which shows the IP address of the default gateway of a host, rp, that enables the creation, editing, and display of mappings of physical addresses to known IP version 4 addresses, show CDP neighbors command, which discovered neighboring Cisco devices running CDP protocol, show CDP neighbors detail command, which reveals the IP addresses of a neighbor device, show IP. Home networks are being used to provide connectivity and internet sharing among multiple personal computer systems and laptops throughout the house. Small scale devices, as long as they provide the same functionality of routing and switching, are all that is needed. These devices are called multifunction devices or integrated routers. For example, the Linksys is a multiple network device that acts as a switch, as a router, and as a wireless access point. As there may be many other wireless networks in your area, it is important that all the wireless devices connect to the correct wide LAN area network. This is done using a service set identifier, SSID, or in other words, a name for your home network. For security, Wired Equivalency Protocol (WEP) is an advanced security feature that encrypts network traffic as it travels through the air. Wi-Fi protected access also uses encryption, but unlike WEP, it generates new dynamic keys each time a client establishes a connection with the AP. For this reason, it is considered more secure than WEP.